You know, it's funny, when you look at a classic brick building or like a massive stone chimney, there is just this overwhelming sense of
Oh,
permanence.
absolutely. It feels solid.
Yeah, I mean, it is literally the benchmark we use for things that will not move. We say something is built like a brick house because we just assume a pile of rocks and cement is virtually indestructible.
Right, but it's a comforting illusion, really. You look at a masonry structure
Yeah.
and your brain just categorizes it as a static, dead, immovable object. It feels invincible to the elements simply because it's heavy.
But then you actually look at the physics of what is happening inside those bricks, especially when extreme weather hits, and
And that illusion just entirely shatters.
completely shatters. We were looking through a stack of technical masonry guides and expert service articles out of Portland, Maine today, and they paint a totally different, frankly terrifying picture of what happens to bricks in coastal winter weather.
Yeah, it's definitely not the static picture most people have in their heads.
Not at all. We are actually looking at a highly vulnerable, constantly stressed structure. It is fighting a daily microscopic battle just to stay upright.
It really is the ultimate definition of structural deception. What looks indestructible is actually incredibly fragile if you don't understand the mechanisms at play. And, Portland, Maine is the absolute perfect laboratory to study this.
Right, because it's basically the ultimate stress test for a building. You're talking about historic brickwork facing relentless exposure to freezing temperatures, driving rain, heavy winter storms,
And
and
that corrosive, salty air blowing right off Casco Bay.
exactly. Over decades, those elements systematically break down mortar joints and completely compromise the structural integrity.
And the beauty of studying this extreme environment for our deep dive today is that if you can understand how to protect a chimney in a harsh coastal New England climate, you can protect a home literally anywhere.
Which brings us to the entire mission for today's deep dive. We are going to build you a definitive, proactive yearly schedule for chimney and masonry care.
Yeah, a real step-by-step guide.
Right. Even if you listening right now don't live in a coastal blizzard zone, understanding these extreme examples will make protecting your own home an absolute breeze. Because while a chimney seems like a pile of bricks you can just, ignore for decades, neglecting it leads to catastrophic, wildly expensive failure.
But if you follow a simple seasonal rhythm, you can save your property. It all comes down to working with the seasons rather than just reacting to damage after the fact.
Proactive instead of reactive.
Exactly. And the biological clock of your house really starts in the spring. When the snow melts, the structural focus shifts entirely to external water management.
The spring and summer offensive.
Yeah.
And the very first item on the spring checklist is something people might not even associate with masonry or chimneys at
Right.
all.
Right.
Clearing your gutters.
Which I know sounds like basic yard work, but it's actually a critical structural defense.
Okay, let's unpack this. Why does a gutter full of leaves threaten a chimney? From what I gather in the sources, it's about water volume and misdirection. When gutters clog, rainwater overflows in massive sheets instead of trickling away. That overflow cascades down the side of the house, absolutely saturating the exterior brickwork. And worse, it pools at the base of the foundation.
And you have to remember, masonry is porous. It absorbs water.
Right.
When water pools at the base, it doesn't just sit there. Through capillary action, the bricks essentially act like a giant sponge, wicking that pooled water upward into the structure.
Wow, just pulling it straight up from the ground.
Yeah, and that constant saturation overwhelms the masonry's natural ability to dry out, which, over time, leads to massive foundation shifting and structural degradation.
So clearing the gutters is your first line of defense, just to keep the sheer volume of water away from the bricks in the first place.
Exactly. It's step one.
But once you secure that and we move past spring into the dry summer months, that is when the real preventative maintenance has to happen. Summer is the window for scheduling masonry repairs and waterproofing. Yeah. And this brings us to one of the biggest aha moments in the sources regarding how mortar actually functions.
Oh, this is such a common misconception. People have a fundamental misunderstanding of mortar. They look at it and assume it's just a permanent glue, that its only job is to stick the bricks together as tightly and rigidly as possible.
But it's not. Mortar is deliberately designed to be the weak point in a masonry structure.
Entirely by design.
Well,
mortar acts as the binding agent, but mechanically, it is formulated to be softer than the surrounding brick.
I was trying to visualize this, and the best analogy I could come up with is that mortar is basically the crumple zone of a house.
Oh, I like that.
Or like a mechanical fuse in an electrical circuit. It is meant to take the hit. The
Yeah.
house settles, the ground shifts, the wind pushes, temperatures cause expansion and contraction.
Right.
The mortar absorbs all those structural shifts so that it cracks and fails before the harder, much more expensive bricks crack. It sacrifices itself to save the bricks.
That is exactly the engineering logic behind it.
Yeah.
But because it is the sacrificial element, it will inevitably erode.
Right, because it's doing its job.
Exactly. Over years of absorbing that movement and weather, it flakes, it crumbles, and the joints become recessed. And when the mortar recesses, it stops being a crumple zone and starts being a tiny little shelf for standing water.
Which is terrifying.
It really is. It becomes an open door for the biggest threat to masonry in existence.
Which brings us back to the Maine weather stress test. When water enters those gaps in the failing mortar, it just sits there. And when the temperature drops below freezing in the winter, that trapped water freezes and expands by exactly 9%.
Yeah. 9% expansion inside a rigid structure doesn't sound like much, but mechanically it is devastating.
Because it has nowhere to go.
Right. Water doesn't just freeze, it crystallizes and pushes outward with immense pressure. It acts like a microscopic hydraulic wedge inside the pores of the masonry. That sheer outward force will literally blow the face off adjacent bricks.
So the summer fix to prevent this winter explosion is a process called tuck pointing. If you have moderate mortar loss, recessed joints, crumbling sand, you have to get it fixed during the dry months. And tuck pointing isn't just a guy with a trowel slapping some wet cement over the cracks.
Far from it. It's an incredibly precise craft, almost an art form masquerading as construction. Professional masons have to use specialized diamond-tipped grinders to route out the failing, crumbly joints to a very specific depth, usually about 3/4 of an inch.
They need to create a clean, solid, rectangular channel so the new mortar has something to bite into, right?
Precisely. If you just smear new mortar over the surface, it'll pop right off after the first freeze. You need that depth.
And what blew my mind is how they handle this for historic homes, like the beautiful vintage properties in Portland's West End. They don't just use standard gray concrete from a hardware store.
Oh no, that would look terrible.
Right. They actually customize the fresh mortar. They mix specific sand aggregates and masonry dyes, so the new mortar perfectly matches the historic aesthetic of the 150-year-old house.
It's amazing to watch.
It really is. They blend it seamlessly with the aged portions, press or tuck the fresh mortar in, and then strike it with a tooling iron so the joint is shaped to physically shed water.
It's brilliant preservation work. But that brings us to the final step of the summer defense, which is waterproofing.
Right.
Once the mortar is fixed, you want to apply a vapor-permeable siloxane sealant. So driving rain just beads up and bounces off the masonry.
Okay, let me stop you right there and play devil's advocate for a second, because the sources are incredibly strict about this timeline, and honestly, it feels counterintuitive.
How so?
Well, they state that once the tuck pointing is done, you absolutely cannot waterproof it immediately. You are required to wait a minimum of 28 days. Why? If water is the enemy and we know rain is coming, why leave fresh mortar exposed for an entire month? Why not just seal it up the moment the mason packs up his tools?
What's fascinating here is the internal chemistry of the mortar itself. New mortar doesn't just dry like paint, it cures through a chemical reaction.
Oh, interesting.
And that process takes a full 28 days to reach its structural strength. During that curing phase, the mortar is constantly releasing its own internal moisture into the air.
So if I go out there on day 3 and spray a waterproof coating over it, I'm trapping all that chemical moisture inside the wall.
Exactly. You are essentially suffocating the mortar before it can harden. The trapped water interferes with the chemical bonding process, completely compromising the structural strength of those new joints.
Wow.
Yeah, they will be soft, crumbly, and virtually useless.
I know what you listening might be thinking right now. You want to go to the hardware store, buy a $20 can of generic water sealer, and spray your bricks this weekend to save a few bucks? Don't do it.
Definitely don't.
The sources make a massive distinction between commercial, vapor-permeable siloxane sealants and cheap hardware store sealers.
That distinction is literally the difference between saving your chimney and destroying it from the inside out. Standard hardware store sealers often contain silicone or acrylics that coat the brick like a layer of plastic.
Right, which sounds good in theory.
Sure, they keep the rain out, but they also act like a plastic bag over the masonry. They trap all the internal moisture from the house, from the mortar, from ground wicking inside the brick.
So the trapped water can't escape, the winter comes, it freezes, and you've basically engineered your own brick-exploding hydraulic wedge.
Precisely. That's why professionals use vapor-permeable siloxane. On a molecular level, the siloxane molecules are small enough to allow water vapor, which is a gas, to pass through and escape the brick.
Oh, that's clever.
But the molecular structure is too tight to allow liquid water drops from rain to penetrate inward. So it lets the masonry breathe while wearing a raincoat, essentially.
That is incredible engineering. So let's look at where we are in the year. Summer is ending. The exterior mortar is fixed. The crumple zone is restored. It has cured for 28 days. And the breathable siloxane sealant is applied. The outside is entirely locked down and secure. But just as we secure the exterior against the freezing rain, the seasons change. We enter heating season. And suddenly, the threat to the masonry stops coming from the sky and starts coming from inside the house.
The fall preparation shifts entirely to internal defenses, because before you start burning cordwood or firing up your heating appliance for the winter, you have to inspect and clean the internal flue.
The fall sweeping. The sources treat this as absolutely non-negotiable.
It really is.
And the primary reason is removing creosote buildup. Now, just to clarify the mechanics here, when you burn wood, the smoke carries unburned particles up the chimney. When that hot smoke hits the colder air near the top of the flue, it condenses into a sticky, highly flammable tar called creosote.
And routine sweeping removes that glaze, preventing devastating chimney fires that can burn at 2,000 degrees and easily spread to the frame of the house.
Which is terrifying.
Very. Sweeping also ensures there are no blockages that could cause deadly carbon monoxide to back up into your living room.
But the fire and gas hazards aren't the only internal threats. And this was honestly the most surprising part of the research for me. The exhaust gases generated by your furnace or your wood stove are highly acidic.
Highly acidic. And mortar, chemically speaking, is alkaline.
Ah.
So if those exhaust gases are not properly vented, the acidic byproducts will literally eat away at the masonry from the inside out. It's a chemical deterioration.
Here's where it gets really interesting, because when I was reading about this acid attack, I instantly thought of the human digestive tract.
Oh, I see where you're going with this.
Right. Your stomach contains incredibly powerful acid to break down food, but it doesn't digest itself because it has a specialized protective stomach lining. A chimney operates on the exact same principle. It is handling extreme heat and highly corrosive reflux in the form of exhaust gases. If it doesn't have a specialized stomach lining, those acidic gases just dissolve the surrounding structural brick.
That is a brilliant analogy. And the scary part is, when that stomach lining of the chimney is failing, you can't easily see it from the outside until the damage is severe.
Right, because it's all hidden inside.
Exactly. But the house will show you symptoms. The warning signs of acid decay are very specific.
Let's run through those. One of the big ones is seeing white, chalky exterior stains on the brickwork. The technical term is efflorescence.
Right.
It's basically the escaping moisture dragging salts out of the decaying brick and leaving a white powder on the surface. You might also notice a musty, damp odor near the fireplace.
You should also look inside the firebox itself. If you find rust flakes or reddish stains, that indicates the metal components are corroding from the acid.
To know.
And if you see actual pieces of crumbling interior mortar falling down, or you experience severe drafting issues like smoke constantly spilling backwards into the room, that means the internal barrier has warped, collapsed, or been eaten through entirely.
Okay, so if the chimney's digestive tract is dissolving, how do we fix it? Because I imagine we can't tuck point the inside of a 30-foot pipe.
No, definitely not. The modern definitive solution is upgrading the internal pathways with durable stainless steel liners,
which act as a permanent, impenetrable barrier. You drop this continuous steel tube down the chimney, and it essentially becomes the new flue.
Yes, exactly.
What I found fascinating is the thermodynamics of this. The stainless liner keeps the exhaust gases hot and buoyant. Because they stay hot, they draft out of the house incredibly fast, preventing them from cooling, condensing into creosote, or lingering to eat the brick.
Right.
It safely drafts corrosive byproducts out, completely isolating the exhaust from the structural brick and mortar.
If we connect this to the bigger picture, you can see how this creates a comprehensive two-front defense system for the home. You have the internal stainless steel liner protecting the structure from acidic chemical decay on the inside.
Right.
And you have the vapor-permeable siloxane waterproofing protecting the mortar from physical freeze-thaw expansion on the outside.
It's a perfect shield. You've neutralized the acid and the ice.
Yeah.
But we are talking about real life here, and human beings get busy.
Very true.
We put things off. We miss our seasonal maintenance. So, what happens if a homeowner misses these spring, summer, and fall beats? Let's say they ignore the fading mortar and just let a harsh Maine winter take its toll on an unprotected system.
That is when we transition from proactive maintenance into the grim reality of structural decay.
Hmm.
And the sources outline how this happens, step by step. It's a progression that ultimately leads to the absolute masonry nightmare.
Demolition.
Demolition.
Let's walk through the 4 stages of deterioration so you listening can evaluate the current state of your own home. Imagine it's October and you are in stage 1, which is early surface wear. This looks minor. It's just some microscopic pitting in the mortar or maybe some color fading where the sun and rain have beaten against the wall.
At this point, the structural risk is essentially zero. But microscopically, those tiny pits are collecting morning dew and holding it.
So what's the fix?
The required action here is simple: preventative sealing. You clean it, apply the siloxane, and you stop the progression entirely.
But let's say you ignore it. The dew freezes, pops a few more sand grains loose, and by next year, you are in stage 2, moderate mortar loss. This is where you can visibly see recessed joints. The mortar looks like a crumbling sandcastle in places.
The structural risk is now moderate. The crumple zone is failing, and those recessed joints are acting as ledges for rainwater to pool.
So sealing it won't cut it anymore.
No, the intervention required jumps significantly here. You can't just spray a sealant anymore.
Yeah.
You need full tuck pointing. The masons have to grind out the joints and pack in fresh mortar.
But our hypothetical homeowner puts that off too. They let those recessed, water-filled joints go through another brutal, freezing winter. The hydraulic wedges do their work. Now we hit stage 3, which is spalling bricks.
This is bad.
Yeah. This is where the 9% ice expansion has shattered the actual brick. The visual indicators are flaking brick faces popping off into the yard and deep, visible cracks running through the masonry.
The structural risk is very high at stage 3. The bricks themselves, the load-bearing elements of the structure, are failing. The required action is spot replacement of the dead bricks, physically cutting them out and sliding new ones in, combined with extensive tuck pointing. It's incredibly labor-intensive.
And if you somehow ignore falling bricks in your yard, you reach stage 4, structural failure. This is an absolute emergency. You look at the chimney stack above the roofline, and it is visibly leaning or twisting. You have totally loose bricks you could pull out with your bare hands. You might even have entire missing courses where a whole row of bricks is just disintegrated.
The risk level is critical here. The chimney could collapse through the roof or onto a neighbor's property.
Which is a nightmare.
Exactly. When a significant percentage of the bricks have spalled and the geometry of the structure is leaning, minor repairs are physically impossible. The only safe path forward is partial demolition and rebuilding.
Before we get into the anxiety of tearing down a chimney, we have to mention the literal top of the structure, which is often the culprit for all of this in the first place, the chimney crown.
Oh yes, the crown is essentially the concrete roof of the chimney. It sits at the very top, sealing the gap between the brick walls and the flue liners, sloping downward to shed water.
And the sources emphasize that even hairline fractures in the crown are a massive threat, because if water gets into a crack on the very top of the chimney and freezes, it blasts the crown apart.
Right.
And if the crown fails, water pours directly into the hollow core of the masonry. It completely bypasses all your exterior siloxane defenses because the water is falling inside the walls.
It's awful.
If a crown is severely cracked, you have to completely remove it and cast a brand new concrete slab.
It's the umbrella for the whole system. Without it, everything else rots.
So let's say the worst has happened. The crown failed, the mortar is gone, the brick spalled. It's stage 4. The chimney is leaning over your driveway. You have to do a controlled demolition. The masons come in and carefully dismantle the damaged upper courses of brick, knocking it down layer by layer to remove all the compromised material until they reach a solid, healthy masonry line below the roof line.
I know this sounds terrifying to a homeowner. The idea of taking down a part of your house and having a gaping hole in your roof during a coastal autumn is panic-inducing.
Definitely.
But professional masons employ incredibly strict weather mitigation strategies.
I was really impressed by the logistics of this. They don't just smash it with a sledgehammer. They build secure scaffolding, wrap the area in heavy-duty tarps, and use temporary roof sealing techniques so the home is entirely protected from rain and wind during the teardown. Your living room is never just left open to the elements.
Which is a huge relief.
Right. But so what does this all mean for someone with a historic home? Does tearing down the chimney completely ruin the historical integrity of the property? Are you stuck with a shiny, modern Home Depot-looking eyesore attached to a vintage house?
This raises an important question. It's a massive concern for property owners, but the answer is no. Partial demolition is highly precise. The goal isn't just structural safety, it is historical preservation.
That's reassuring.
Right. The structure is rebuilt, course by course, using new materials that meet modern fire and building codes, but the masons go to great lengths to match the historic aesthetic.
Right. They use the same colored mortar techniques we talked about earlier, the same style and color of brick. They can even source reclaimed vintage bricks in some cases. It is a very delicate balance of preserving the historical look while implementing modern physics and safety standards underneath the surface.
It's about making it look like it has always been there, while ensuring the internal engineering actually survives the next century.
Okay, let's bring this all together. We set out to build a definitive yearly schedule for your chimney and masonry care. And we've covered the physics, the chemistry, and the architecture of it all. So let's distill it down into the core rhythm you need to remember as a homeowner.
Right. So, spring. Clear your gutters, manage the water volume so it doesn't pool, wick up through capillary action, and saturate your foundation.
Summer. Utilize the dry weather to fix your crumple zone. Have the failing mortar repaired with proper depth tuck pointing. Wait the mandatory 28 days for the chemical curing process to release its internal moisture.
Right.
Then apply a breathable, vapor-permeable, siloxane waterproofing sealant to block the rain.
And then fall. Sweep the flues to remove the highly flammable creosote tar. Inspect your internal stainless steel liners and ensure those highly acidic exhaust gases are drafting safely out rather than eating your chimney from the inside out.
By adopting this yearly rhythm, you are doing so much more than just checking off household chores. You are actively extending the life of your structure by decades. You are preventing the terrifying structural emergencies of a leaning, collapsing chimney. And frankly, you are saving yourself massive, massive demolition and rebuilding costs.
It really is the difference between small, predictable, manageable maintenance and sudden, catastrophic failure.
Which brings us right back to where we started today. We tend to look at brick and mortar as dead, static objects, a permanent pile of rocks sitting on the side of a house.
But they're not.
No. As we've learned from studying the harsh coastal weather of Maine, a chimney is actually a highly dynamic, almost breathing machine. It is a structure constantly battling freezing, expanding water, trying to tear it apart on the outside, and highly corrosive, acidic fire, trying to dissolve it on the inside. It is fighting a two-front war every single day, just to stay standing.
It completely changes how you look at the entire building, doesn't it?
It really does. It makes you wonder, what other seemingly solid, indestructible elements of your home are secretly fighting an invisible daily war against the element, just waiting for you to give them a little proactive reinforcement?
I think we all have a few areas of the house we might want to go double check after this.
I know, I'm looking at my gutters differently tonight. Keep an eye on those bricks, and we'll see you on the next deep dive.